Measures of center. Mean of a data set. The mean of a data set is the sum of the observations divided by the number of observations. Sample mean. For a variable x, the mean of the observations for a sample is called a sample mean and is denoted by x bar. Symbolically, x bar equals the sum of x sub I divided by n, where n is the sample size. The summation symbol, it looks like an E, means add up all of your data points. I denotes the number of data points, whether we have 2 data points or 100 data points. N is the sample size, and x bar is the symbol for sample mean. Example: pesticides are chemicals often used in agriculture to control pests. In a certain country, a large percentage of the population depends on agriculture, and pesticide use there has increased rapidly. In an experiment, researchers sampled the most commonly used fruit in this country and analyzed the pesticide residues in the fruit. The amounts in milligrams per kilogram of a certain pesticide for a sample of fruits are given in the table. We have 0.2, 1.1, 3.8, 5.6, 5.6 again, 11.1, 0.1, 3.5, 2.3, 6.7, 4.1, 2.6. Find n. N is the number of data points. If we count up our data points, we find that we have 12. So n equals 12. Compute the sum of x sub I. What they want us to do to find that sum is to add up all of our data points. Once we add up our data points, we find that the total is 47.3. Determine the sample mean. Round to 2 decimal places. To find the sample mean, we need the sum of the data divided by the number of data points. 47.3 divided by 12 is 3.94 when rounded to 2 decimal places. The sample mean is 3.94 milligrams per kilograms. Example: compute the mean strength of the concrete. A concrete mix is designed to withstand 3,000 pounds per square inch psi of pressure. The following data represent the strength of 9 randomly selected casts in psi. Our data set is 3,960, 4,090, 3,100, 3,200, 2,940, 3,820, 4,090, 4,050, and 3,420. To find the sample mean, we need to total up our data and divide it by the number of data points. We were already told that we have 9 data points. Now we just need to add our 9 pieces of data. Our total for the data is 32,670, and we want to divide that by 9. That gives us a mean of 3,630. So the mean strength of the concrete is 3,630 psi of pressure. Median of a data set. Arrange the data in increasing order. If the number of observations is odd, then the median is the observation exactly in the middle of the ordered list. If the number of observations is even, then the median is the mean of the 2 middle observations in the ordered list. In both cases, if we let n denote the number of observations, then the median is at the position n plus 1 divided by 2 in the ordered list. Example: compute the median strength of the concrete. Again, we're using our concrete data. So the first thing we want to do is put it in numerical order. 2,940 is our smallest piece of data, then 3,100, 3,200, 3,420, 3,820, 3,960, 4,050, 4,090, and 4,090 again. We have 9 pieces of data. 9 plus 1 is 10, divided by 2 is 5, so the 5th piece of data is 3,820. Another way to compute it is to pair off the data points on the end. So I pair off my first and last data point, second and next to last, third, third to last, fourth, fourth to last, and my middle is 3,820. So we have 3,820 psi of pressure. Mode of a data set. Find the frequency of each value in the data set. If no value occurs more than once, then the data set has no mode. Otherwise, any value that occurs with the greatest frequency is the mode of a data set. Example, using our concrete data again, compute the mode strength. The number that occurs the most is 4,090. So the mode of this data set is 4,090 psi of pressure. Mean and median. The following 3 graphs show the relative positions of the mean and median for A, right skewed distributions, B, symmetric distributions, and C, left skewed distributions. For the right skewed distribution, the median comes before the mean. Since our line for our distribution will always be a number line, this means that the median will always be smaller than the mean for a right skewed distribution. For a symmetric distribution, the median equals the mean. For the left skewed distribution, the mean comes before the median. This means that the mean is smaller than the median. Example, determine the mode of the data. The response of a sample of 2,000 people who were asked if their next vehicle purchase will be foreign or domestic. Foreign, 762. Domestic, 1,015. Don't know, 223. To find the mode, we want to find the highest frequency, which is domestic at 1,015. So the mode is domestic. Decide whether it would be appropriate to use either the mean or the median as a measure of center. Explain your answer. So we have the same data set with our foreign, domestic, and don't know responses. Because our data, which is foreign, domestic, don't know, are qualitative, they're just labels. We cannot add foreign, domestic, and don't know and divide by 3. We can do math with their frequencies, but not with the data. We can also not do math with the median. Since the data is qualitative, neither the mean nor the median can be used as a measure of center. To recap the section, measures of center. Mean of a data set. The sample mean, represented by x bar, is the sum of the data divided by the number of pieces of data we have. Median of a data set. Once the data is ordered, the median is the middle. Mode of a data set. For the mode, it is the data point that occurs the most, whether it's 1 number, 2 numbers, 3 numbers, so on. If no numbers repeat, then the data set is said to have no mode.